right, hi guys. Today we are going to be solving quadratic equations by using the quadratic formula. What I want you to do for a minute is I want you can pause the video if you need to, but get your green formula chart and I want you to put your finger on the quadratic formula. Should be down towards the bottom. Pretty big formula, right? Well, the reason we have that formula is because a lot of times, as you saw before, some of the quadratic equations were set up to be easily factored and some were set up to be easily solved by a square root. But sometimes neither of those methods work. So when they don't work, you can always solve with quadratic formula. The quadratic formula can be used for any quadratic equation. However, sometimes you might find using factoring or square roots an easier method, but the quadratic formula does indeed work for any quadratic equation. So let's look at that formula. That formula here states that x is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So take a moment. If you need to pause the video, I want you to write down this quadratic formula. Got it? All right, let's go to our first example. When we're working with the quadratic formula, we want to make sure that our quadratic equation is in standard form. And we, of course, want to set it equal to 0. So to solve this, we need to identify what is our a coefficient, what is our b coefficient, and what is our c coefficient. So I like to go off to the side. Oops, let me get a marker. A is equal to 6, the coefficient. Our B is equal to a positive 5. And C is equal to negative 4. So now we're just going to fill that into our equation. So if we come over here, I'm going to change my pen. X is equal to negative b. Well, what was my b value? Right there, it was a 5. So negative 5 plus or minus the square root of b squared. So again, that value of 5 squared minus 4 times my a value, which is 6, times my c value, which is negative 4. And that's all going to be over 2 times my a value, which is 6. Once you have this, then you're just going to start simplifying that equation. So again, x is equal to negative 5 plus or minus, well, what is 5 squared? 5 squared is 25, so we're going to have the square root of 25 minus, next we need to multiply 4 times 6 times negative 4. Multiply all that together, you get 96. Oh, but that's a negative 96, which means it's going to change that sign to a plus. Because we don't write minus negative 96, so go ahead and change it to a plus. And that's all over 12. All right, you can see we still have some more simplifying to do. I can do addition underneath that radical. So x is equal to negative 5 plus or minus the square root of 121 all over 12. Again, I hope you recognize that the square root of 121 is a nice, pretty, perfect square. I'm going to move up here. So I could rewrite this as x is equal to negative 5 plus or minus 11 all over 12. So this is just like where we had factoring. I've got that plus or minus. So I'm going to set up two separate equations. The first equation I'm going to do is x is equal to negative 5 plus 11 over 12. And then my second equation, I'll drop down here, x is equal to negative 5 minus 11 over 12. Let me go back and put my 1 there. And then we just finished solving this out. Negative 5 plus 11 is 6. over 12, which we know that that does simplify to 1/2. So x is equal to 1/2. Down here in the blue, -5 minus 11 is equal to -16 over 12. And we know that that can simplify to x is equal to -4/3. And it's totally okay to leave it in improper fraction. Because if I were to simplify this to a decimal, it's going to be a repeating decimal, and we do not leave repeating decimals as decimals. We're going to get an exact answer, so fraction form. So there would be my answer. X is equal to 1/2, or x is equal to -4/3. All right, let's try another one. I know the formula looks big and scary, but once you just identify the parts, it's just a matter of simplifying. All right, first step, let's identify our A, our B, and our C. A is equal to 2. B is equal to -8. C is equal to 1. So here's our quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Right here. Again, it's always found on your formula chart. Next, we're going to substitute in our a value, our b value, and our c value. So x is equal to -b. Well, b is -8. Do not forget that you're taking negative of your entire b value. So if that b value is negative, you're going to see when we simplify it, it really turns it to a +8. So -b plus or minus the square root of b squared, so -8 squared, minus 4 times a times c, all over 2a, so 2 times 2. Now I want you to pause the video and see how far you can simplify it before you feel like you need to start it again and check your answers. All right, let's go and simplify. So x is equal to, the first thing I'm going to simplify is negative times -8, which that would make that as a +8, because it would be -1 times -8, plus or minus the square root. Well, when we look here, -8 squared is going to be 64. And then -4 times 2 times 1 right there is going to be -8 all over 4. All right, we can simplify under the radical. X is equal to 8 plus or minus the square root of 56 all over 4. All right, we're not done, because even though, hope you recognize that the square root of 56 is not a pretty perfect square, but we can simplify this. This goes back to simplifying the radicals. So I'm going to go over and I'm going to do some side work. I need to simplify the square root of 56. Remember what we talked about? We're going to break it down. What two factors do you think of when you multiply together to get 56? I think of 7 times 8. Are either of those a perfect square? Nope. But can we break anything else down? 7 doesn't break down because it's prime. So square root of 7 times, but I can break down 8 into 4 times 2. Hopefully you recognize that 4 is a perfect square. So I could bring out the 4. That becomes perfect square. Square root that is a 2. And then I cannot break down 7 anymore. I cannot break down that 2 anymore. So we're just going to put it back together. 2 square root 14. So now I'm going to put that in place of square root of 56. So x is equal to 8 plus or minus 2 square root of 14 all over 4. Now that looks very good, except I could do one more thing. I can still simplify. I'm going to rewrite this over here so I have some more room. X plus or minus 2 square root 14 over 4. Well, what I would like for you to notice, I would like for you to notice that 8, 2, and 4 all have a common factor. What's that common factor? A 2. So I can divide each of them by 2. So 8 divided by 2 is 4, plus or minus 2 divided by 2 is 1. I really don't need to write that 1 right here. That's just imaginary, but it's not needed. Just kind of like writing 1x is not needed. So 4 plus or minus the square root of 14 all over. Take that denominator, 4 divided by 2 as well, is equal to 2. There is my final answer in simplified radical form. Remember, you're not going to have a calculator, so we're not going to be getting a decimal answer. A decimal answer would produce an approximation because we know that non-perfect squares do not terminate, they do not repeat. So at some point we would have to round our answer. This right here gives us an exact answer. How'd you do on your simplifying? Hope you did well. Let's try another one. Number 3. What's different about this one? It's not in standard form. So the first thing we need to do is we need to move x plus 20 to the other side, so that way it is in standard form. I am going to subtract x from both sides. I'm going to subtract 20. So minus x minus 20 gives me my new equation of x squared minus x minus 20 equals 0. Now I'm ready to identify A, B, and C and then use my quadratic formula. A is equal to 1, B is equal to -1, C is equal to -20. All right, I want you to pause the video and I want you to try this one. See how you do on it. All right, hopefully you've worked as far as you can, maybe even all the way and got an answer, got your solutions. But let's go over it. So x is equal to -b, so that's negative, and then my b value is a -1, plus or minus the square root of b squared, so that's -1 squared, minus 4ac, so 4 times 1 times -20, all over 2 times a, so 2 times 1. Now we're ready to simplify. -1, that -1 outside the parentheses, times the -1 in the parentheses just gives me a +1, plus or minus the square root. -1 squared is just 1. -4 times 1 times -20. So all of this right here, that gives me a -80. No, +80, I'm sorry, because we have two negatives there, the -4 and the -20. All over 2. Now we can keep combining terms underneath the radical. So x is equal to 1 plus or minus the square root of 81 over 2. Do you recognize that perfect square? I hope so. So we have x is equal to 1 plus or minus 9 all over 2. I've got the plus 9 and the minus 9, so I'm going to have to break this down into two equations. So x equals 1 plus 9 over 2, and x equals 1 minus 9 over 2. So 1 plus 9 is 10 over 2, which gives me x equals 5. On the minus 9 equation, 1 minus 9 is -8 over 2, gives me x equals -4. There are my two solutions. My parabola would cross the x-axis at -4 and +5. How'd you do? Hope you did well. All right, you try this one. Pause the video. See how far you can go. If you get stuck or you reach the end, go ahead and turn the video back on. I'll give you a hint. You should get a nice, pretty, perfect square. So that should be a little bit easier for you. All right, let's identify our A, B, and C. So I identified A as -3, B as a +5, and C, oops, that 5 didn't write. C is equal to a +2. All right, now we're just going to substitute in for the quadratic formula. X is equal to negative B value, so -5 plus or minus the square root of B squared, so we have 5 squared, minus 4 times A, which is -3, times C, which is 2, all over 2 times A, so 2 times -3. Let's simplify. X is equal to -5 plus or minus the square root 25 plus 24. -4 times -3 is 12. 12 times 2 is 24. And that's all over -6. Still combining under the radical. -5 plus or minus the square root of 49 over 6. Come up and make a separate column. So hopefully you can see that that becomes X is equal to -5 plus or minus 7 all over, -6. I forgot the negative back there. Okay, break it down. Let's do two different equations now. X is equal to -5 plus 7 over -6. X is equal to -5 minus 7 over -6. The first one, X is equal to 2 over -6, which simplifies to a -1/3. The second equation, X is equal to -12 over -6, which makes X equal to a +2. How'd you do? Hope you did well. All right, I think we got 2 more examples left. All right, this example. This one's going to give us a little bit of a different answer. You're welcome to go ahead and try to work it out as far as you can go, but we can also do this one together. Again, we're identifying A is equal to 1. My B value is -4. My C value is equal to 5. All right. X is equal to -B. So that's going to be B value is -4 plus or minus the square root of B squared. So -4 squared minus 4 times 1 times 5, all over 2A, so 2 times 1. So X is equal to 4 plus or minus square root of 16 minus 20, all over 2. Keep simplifying. X is equal to 4 plus or minus the square root of -4 over 2. Now, I hope you recognize and say to yourself, wait a minute, we've never done a square root of a -4. When you see a negative number underneath the radical, that means there are no real solutions. Your solution becomes what we call an imaginary number, but that's not something you'll learn about until Algebra 2. All that we know about this that we're going to worry with is that there is no real solutions, meaning that the parabola will not cross the x-axis. Will not cross the x-axis. It will not cross the x-axis. So it could be a situation that we've seen sometimes where parabolas are just like this, where the vertex does not cross the x-axis. That would be an example of something within an imaginary or a no real solutions. Because remember, we had stated earlier that the solutions are the same things as the zeros. We also call them the roots or the x-intercepts. There are no x-intercepts, therefore there are no real solutions. All right, last one. I want you to try this one on your own. Try this one on your own. You can verify with your neighbor, and we will go over this one tomorrow. Hope you had fun learning the quadratic formula, and I can't wait to see you guys tomorrow. Bye.